Hello, welcome to another class with Mathemasoft. And in today's class, we shall continue with our study in quadratic equation. In today's class, we'll be looking at the nature of quadratic roots. And we are going to start from what we have known so far down to what we're supposed to know under this topic, nature of quadratic equation. So, from our previous knowledge, we already have it that a quadratic equation must be such that can be expressed in the form ax squared plus bx plus c equals 0. And under the sum of roots and product of roots, we already look at the sum of quadratic roots representing the two roots with alpha and beta, and we already look at the product of roots, that this can be expressed as minus b over a, and this can be expressed as c over a. What is important for us to also remember is that a quadratic equation will always have two roots, okay? And this is what we represent here with alpha and beta. Before we move further, we must also look at the nature of a quadratic graph. And by saying the nature, I mean the appearance of a quadratic graph. A quadratic graph will always appear in two forms. It is either what N shape or U shapes. These are the two basic shapes we can give to a quadratic equation. And these are the basic shapes for a quadratic graph. Okay, so here we say it is N shape, okay, and here it is what? U shape. Okay, here we are going to have what we call maximum points, okay, because this is N shape, so the value here is going to be what? Maximum at this place. Just look at mountain the same way you look at the peak of a mountain. So the peak of an N-shaped quadratic graph will give us what? The maximum point. So we can actually get out our maximum value there. And also, the U-shaped quadratic graph will also give us the minimum points. It is minimum because we can compare these to a valley. Okay, so we can compare this U shape to a valley. So the minimum point can actually be gotten here, and then we can actually bring out our minimum value. So maximum, minimum. Now, comparing this with the general form of a quadratic equation, the nature of this, our A, in this general form is what will tell us if a quadratic equation will be N-shaped or U-shaped. And it's very important for us to actually note this. When A is greater than 0, that is, when the value of A is what? Positive. Then we say this, we are going to have a U shape, okay? A U-shaped quadratic graph. And from here, we are going to have what we call minimum points. When A is less than 0, then we say that is A is what? Negative. A has a negative value. Then this is going to be N-shaped quadratic graph. And from here, we are going to get maximum points. So it is very important for us to recall this, that here A is greater than 0, and here A is less than 0. So when A, the value of A is less than 0, we are going to have an N-shaped quadratic graph. And when the value of A is greater than 0, we are going to have a U-shaped quadratic graph. This is very important for us to note as basic. Now that we have this background, let's move on with the nature of quadratic roots. Now let us note, in the introduction to this topic, I explained that what the roots of a quadratic equation can be, they can be the same, which is equal, okay? They can be unequal, okay? And they can be imaginary. So it is very important for us to actually have a basic view of what we are about to do. What we are about to do is for us to be able to predict what will be the nature or the feature of the quadratic roots. Will they be equal? Will they be unequal? Will they be real? Or will they be imaginary? So it is very important for us to note that this is actually what we want to test. This is what we want to know generally about the nature of the quadratic roots. They can be real, they can be equal, they can be unequal, and they can be what? Imaginary. And this is exactly what we want to test out. From the general form of the quadratic equation, using the completing the square method, okay, which we have done in some of our classes under quadratic equation. So we generated the quadratic formula that minus b plus or minus root b squared minus 4ac over 2a. This formula can be rewritten as minus b plus or minus root d all over 2a. And this d that we have here is called discriminant. The discriminant d obviously is equals to b squared minus 4ac. It is very important for us to note that we use these discriminants to discriminate the nature of the roots of a quadratic equation. We can use the discriminants that we have here with the formula b squared minus 4ac to determine if the roots of a quadratic equation, without finding out the roots, without solving for the roots, we can use it to predict that the roots will be real or equal or unequal or imaginary, just by knowing the value of our discriminants. So let us look at various values that discriminants may have and what the interpretation will be under this. With the value of discriminants, will the quadratic roots be real? Will they be equal? Will they be unequal? Or will they be imaginary? That is the next thing that we want to do now. When d equals 0, that is, when d, okay, equals b squared minus 4ac equals to 0. So when you perform this from a quadratic equation and then you have it equals to 0, then your discriminant is equals to 0. Now let's look at the interpretation. Then the roots are real and equal. So in any case, when we test out our discriminant, we find our discriminant and we find out that the discriminant is equals to what? 0. Then we can say categorically that what? The roots of the quadratic equation, they will be real. They actually exist. The solution exists. They are real and they are actually equal. In other words, if it's actually 1, it's going to be what? Twice 1. If it's what? If x is 1, it's going to be 1 twice. If it's 2, it's going to be what? 2 twice. So they are going to be equal. They are going to be the same. Now, it's important for us to look at how this will look like. Don't forget, in one of our classes under quadratic equation, we have actually explained, okay, that the solution to a quadratic equation is the point where the curve of the quadratic graph cut the x-axis. This is the y-axis, this is the what? X-axis. So in other words, the point here, the point here are actually the one that give us what? The roots of this quadratic graph. So reading out where this curve cut the x-axis here and where they cut it here will tell us if this quadratic graph actually have this so roots or this root. So of course, looking at this, we know that what? Here is negative, here is positive. So it means that whatever may be the quadratic equation here, we have one value, maybe let's say -1, and we have another value, let's say 2 on this side. So where the curve cuts the x-axis is the solution of your quadratic equation. So knowing that, now we can sketch what the curve of this quadratic equation under this condition when d equals to 0 will look like. Okay, so since we have equal roots, okay, that is just only we have two roots but they are equal. So if they are 1, both of them will be 1. If they are 2, both of them will be 2. So we don't know if it falls on the negative or the positive. We just want to show the way it's going to look like on the graph. Okay, so such that the graph the curve will only touch the x-axis just at one point because the value is the same. So if it's actually 1, both of them are 1. That means that this curve must only cut the x-axis or touch the x-axis just at one point because the value is the same. Let's say this place is actually what? Let's say the value here is 1. Okay, or we may not attach any value. Now the condition here is when a is greater than 0. Of course, you can see that this is U shape, and what it means is that what? Our value of a is actually what? Greater than what? 0. And it may be the N shape also. Okay, just at one point. Okay, that's when a is less than 0. So these are the two conditions, okay, of how the graph of a quadratic equation whose discriminant equals to 0 will look like. So when d equals to 0, the roots are real and they are what? Equal. So the second condition, when d, okay, is greater than 0, we say that is d value is positive. So the value of your d will be a positive what? Value. That's, of course, every positive number are greater than what? 0. So the value of d will definitely be positive here. Then the roots are real and unequal. Okay, so in this case, when the value of d is greater than what? 0. That is, the value of d give you what? A positive number. Then the roots of the quadratic equation will be real. They truly exist, but they will be what? Unequal. In other words, the roots will be what? Different in this case. So we're having two distinct roots for this kind of quadratic equation. And if we are to bring our graph just like we did here, so we are going to have something like this. Okay, it will cut the x-axis in two distinct places. That is, it will have two distinct, two different, two unequal value, okay, which will be our root. This is when a is greater than what? 0, and this is the second condition. Okay, if it's n shape, that will be when a is less than 0. So y, x, y, x. So this will be how the second condition will look like. So let's look at the third condition. The third condition and the fourth condition are going to be established under this what? Second condition. Okay, and we are just going to be brief with that. Okay, it's just an additional information to the nature of the roots. When d is greater than 0 and a perfect square. Okay, when the value of d is greater than 0 and d is a perfect square, of course, you know what perfect squares are. 16 is a perfect square. Okay, 9 is a perfect square. 25 is a perfect square. Root 9, 3, root 16, 4, root 25 is 5. So these are perfect square. So when you have something like this, if your d is such a number that is a perfect square and is also greater than 0, then the roots are real, okay, unequal, yes, they are different, and rational. In this case, the roots will not just be real and unequal, but they will be rational. What are rational numbers? Rational numbers are numbers that can be expressed as a ratio. Okay, 2 is rational because you can write 2 as what? 2 over 1, which is what? 2 ratio 1. Okay, so any number that can be expressed as a ratio is actually what? Rational. In fact, the word rational is derived from what? The word ratio. So when you check our class under sorts, you will understand this more. So these roots here, with this condition, d greater than 0 and the perfect square, will be real, unequal, and also what? Rational. The graph under this third condition is the same thing with this. Okay, there will still be what? Two unequal roots. Okay, two distinct what? Roots. The only thing is that what? The roots now in this case, they will be what? Rational. That is, you can have your what? Something like x equals to 2 or 1. Okay, 2 is a rational number, 1 is a rational number. So that's what we are talking about in this case. So the fourth condition is also like that. When d is greater than 0 and not a perfect square, okay, and not a perfect square, then the roots are real, unequal, and irrational. So in this case, the roots will not be rational, but they will be what? Irrational. Once you have your d, take for instance now, let's say my d gave me something like roots. My d actually gave me something like 17. Okay, if you put this in your quadratic what formula, that will be root d. This root d that you have here, it will be what? Roots. Eventually, it will give you root 17. Okay, and root 17 is actually what? Irrational, because when you look at the root of prime numbers generally, root of prime numbers generally, root 2, root 3, root 5, root 17, they will give you a rational number. They cannot be expressed as what? A ratio. So when your D does not result to a perfect square, that is not a perfect square, although greater than 0 but not a perfect square, then although your roots will be real, they will be unequal, but in this case they will be what? Irrational. That is what? What we have as the value of your root will be rational value. So, but the graph will also be like this. It will also be like this, the same root, because it's still what? Real and unequal. So this is what you have. The only thing is that what? The root here will be irrational. So that's our fourth condition. Now let's talk about the fifth condition and the last. Okay, so the fifth nature is when D is less than 0. Okay, so what we can say about this is that what? It means that what? The value of D is what? Negative value. Okay, when the value of D give you what? A negative value, then the roots are, okay, imaginary and unequal. So in this situation, okay, we say that what? The roots exist as conjugate pairs. So in this case, we can say that the roots exist as conjugate pair. I'm going to explain what we mean by conjugate pair actually, but if you have actually gone through our class under SOD, then you will understand what I mean by this. But let's first explain this. Now, in this situation, it means that what? The value of the quadratic roots will be imaginary, okay? They are not real, okay? The solutions do not really exist. They are imaginary, but they will be what? Unequal. So they will exist as what? Conjugate pairs. Take for instance, if I have my D equals to, let's say, minus 17, okay? So you know that minus 17 is actually what? Less than 0. So in this case, the quadratic roots, they will exist as what? They will be imaginary, and they will exist as what? Conjugate pair. Now in conjugate, when we say conjugate pairs really mean that they will exist with just the difference in their sign. Okay, let's say one value x equals to 2 plus root minus 17. Let me use that one. The other one will just be or x equals to 2 minus root minus 17. So I don't want to go deep about explaining what we mean by conjugate, but this is what it looks like. Okay, so this is going to be this and this, they are pairs. Okay, so they are conjugate what? Pairs. In other words, if you look at the difference, they are the same. The only thing that is different is that there is plus here, there is minus here. So by the time you're going to get your root also of these quadratic what? Equations with this condition of D less than 0, they are going to exist like something like this. So the only difference in them, you can't really find the real value, okay? But by the time you check in between the sign that is joining perhaps, you know, a real number with the other one that is that makes it imaginary, you will see that the difference will just be that one will be plus, the other one will be what? Minus, and then we call them what? Conjugate pairs. That word from SOD, you know, if you have 2 minus root 3, take for instance, this is conjugate to this, okay? So this is the conjugate of this, and this also is the conjugate of this. In other words, under SOD, if we want to rationalize this, we use this. If we want to rationalize this, we use this. So under SOD, in our SOD class, you will understand that better. So for this is what we mean by the root will exist as what? Conjugate what? Pairs. So in this case, the graph will look like something like this. Since there is no solution, then it means that what? The curve will not be touching x-axis anywhere. Just to tell us that what? There is no what? Real value. Okay, so it's not touching x axis, and that means that what this quadratic what graph is showing us that the quadratic equation does not have what any solution. So it's going to be like this for a greater than what 0, and it's going to be like this for a less than what 0. These are y, these are what x. So these are going to be the curve will not, the parabola will not be touching what the x axis. So these are the 5 conditions, okay, and the 5 breakdown of the nature of quadratic what root. It is very important that you understand this the way I've broken it down, okay, so that you can apply this knowledge in solving problems, because there are so many questions, overwhelming questions that can arise from this, that you may have to just use the nature of what the quadratic root will be to solve the questions that you may be given. Okay, so let's try to do the summary of this. Let's try to do summary of this, okay, so that we can put everything together. So I want to give you this summary so that at a glance you can recall everything we have done in today's class. So we have something like this. So let's call this the real number. Let's call this our discriminant. Okay. Let's call this nature of roots. So the first condition is d equals what? 0. That's what we look at. D equals to 0. So we say that what? The roots will be what? Real and equal in this case. So 2, d greater than 0, real roots and unequal. Okay. 3, d greater than 0 and a perfect square. Okay. Real roots, unequal, and rational. Okay. Number 4, d greater than 0 and not a perfect square. Okay. Real roots, unequal roots, and irrational. Okay. So number 5, then we have d less than 0. So when d is less than 0, we say that what? The root will be imaginary, okay, and unequal. That is, they are going to exist in conjugate pairs. So this is what we have under the nature of quadratic roots. Do share out this video with other students around you. Subscribe to this channel if you have not done so, and hit on the notification bell. Let me have your comments and feedback in the comment section. Give me a thumbs up by liking this video, and we will be looking at questions that may arise from this nature of quadratic roots in our subsequent classes. There is still a little part that can also help us to understand, okay, what the root of a quadratic equation will be like. I'll be doing that in the next video. Thank you very much for staying with me on this video. God bless you, and I wish you all the very best in your studies. Bye for now.